Alright, this is part 2 of our lesson on the relationship between arcs and angles. Here we go. Alright, I'm looking for the measure of angle 1. Which formula am I going to use? This one. When the angle is outside the circle, the angle is equal to the big arc minus the small arc divided by 2. So, alright, I see angle 1 that I'm supposed to find right there. Now, where are the two arcs in this picture that I'm dealing with, the big arc and the small arc? Well, they are right here. Okay, here's the big arc that's being intercepted by this angle. And then here is the small arc. Alright, those are the two arcs in question. I see what the big arc is. It's 170 degrees. But the small arc, I don't have that. How could I get it? Well, if I realize that I have the whole rest of the circle, okay? The big arc and this other arc over here make the rest of the entire circle. So if I want the missing piece, all I have to do is subtract from 360. So let's see. I'm subtracting 170 and 135. That is 55 degrees. So that tells me that the small arc here is 55 degrees. So the formula is this. I need to go a little bit smaller because I'm low on space. The formula is angle equals big arc minus small arc divided by 2. So here I go. The measure of angle 1 is equal to the big arc, which is 170, minus the small arc, is 55, divided by 2. Okay, so I can go ahead and say that the measure of angle 1, just put this into your calculator. 170, 55. What is this, a decimal? 57.5. Alright, it always makes me nervous when it's a decimal, so I'm going to go back and double check it. But for now, I'm going to declare this is the answer to number 9. Okay, once again I see angle 1. That's my target. And once again, I'm outside the circle, so I am using this formula where the angle equals the big arc minus the small arc divided by 2. So, in this picture, what is the big arc and what is the small arc being intercepted? Well, I'm glad you asked that question. The big arc is this. Okay, this is the big arc that's being intercepted by the angle. Okay, the small arc is this. Alright, we've got the big arc and we've got the small arc. Now, because this, the sides of this angle are tangent to the circle, it actually makes it so that the big arc and the small arc take up the entire circle. So we're going to use that to our advantage in a minute. So, now, looking at this 64, which is the only actual number that they gave us, is there a way that I can use this 64 angle here? So I've got the 64. How can I use that to find the purple arc? Well, if you understand that the angle is an inscribed angle because of the way the vertex is on the circle, and then you realize that the angle is half the arc. Okay, we memorize that. Or you could say that the arc is double the angle. Okay, so this purple arc should be double this angle. So double 64 is 128. So there, I just discovered something. Alright, need a little bit more room. So this purple arc here is 128 degrees. Okay, I've got the small arc now. I still need the big arc. Hold on, that's bothering me. Let me just put it like this, 128 degrees. Alright, now because the small arc and the big arc take up the entire circle, I can just subtract from 360. So I'm just going to do 360 minus 128. Whoops. That's 232 degrees. Okay, so the big arc over there is 232 degrees. That's a little bit too much. So 232 degrees. Alright, now I'm ready to do the formula. So the measure of angle 1, which is my target, should equal the big arc minus the small arc divided by 2. So that should equal 232 minus 128 divided by 2. 52 degrees. So the measure of angle 1 is 52 degrees. And that's the answer to number 10. Alright, number 11. This is very similar to the last problem. It's a tiny little angle here, peeking outside the circle, but we are still going to be using this formula for when we have the angle outside the circle. So angle equals big arc minus the small arc divided by 2. So in this picture, this is the big arc that's being intercepted by the angle. Now the small arc is this little guy right there. Now one of those we know what it is, the other one we don't. So we have the big arc, but we need the small arc. Fortunately, we have the entire rest of the circle. We have everything except for the small arc. So I could just subtract these three other numbers from 360, since 360 is the total of the circle. This is the easiest way to type that in, just 360 minus 95 minus 85 minus 175, boom. 5 degrees. A small angle indeed. Okay, so this is 5 degrees. So that's enough information. We needed the angle is equal to, so I can just say the measure of angle 1 is equal to the big arc minus the small arc, so 85 minus 5 divided by 2. So the measure of angle 1 is going to equal, well, 85 minus 5 is 80. 80 divided by 2 is 40. So the measure of angle 1 is going to be 40 degrees. And that's the answer to number 11. Okay, number 12 is a little tricky. It's like two problems in one, and you have to solve the first one before you can solve the second one. So look, this is our target. We're supposed to find the measure of angle 1, and you see that it is an angle that's outside the circle. So you know that we're doing angle equals big arc minus the small arc divided by 2. So we have to look at the picture and decide where's the big arc, where's the small arc, like you do. And we can see that, you know, looking at the angle and how it's striking the circle, this is the big arc that is being intercepted. Okay, that's 93. So far, so good. And but this is the smaller arc, all right, which we don't have. So we need to find the smaller arc. So I'm looking around, and in the last couple of problems, I had the entire rest of the circle given to me. So I could easily find, I could just subtract from 360. But this time I don't have the rest of these arcs, so I need a different strategy to find this missing arc. So let me give you a hint. Now here I've copied the same picture over again, but I've left out the distracting angle that's cutting through the picture. Now our goal right now is to find this arc, the small arc. And we have a way to do that, do we not? So here's the small arc right here. I'm going to color it the same color. So this is what we're looking for, this purple arc. Okay, but we have the big arc. We have this. Now looking at this picture, let's see what we're dealing with. Alright, that's this picture. Alright, we have an angle inside the circle, and we know that the angle is equal to arc plus arc divided by 2. So in this case, I'm going to put a little X on the purple part, since that's what I'm trying to find right now. The angle, 65 degrees, should equal arc plus arc divided by 2. So that's what I'm going to do. Angle equals arc plus arc divided by 2. So I should be able to solve this problem and find this purple arc. So to do that, once again, I will multiply both sides by 2. And these will cancel. Let's see. It's 120, 130 is equal to x plus 93. Subtracting 93 on both sides gives me 37. Alright, so x is equal to 37. Alright, now remember, that's this right here. So this purple arc is 37 degrees. So that's the end of this little side problem. Now we can go back to number 12 and do what we need to do. Because to find this angle outside the circle, remember we were using this formula. The angle is equal to the big arc, the big arc minus the small arc divided by 2. So now I have the big arc and the small arc, so I can actually do the problem. Okay, so here I go. So I will say the measure of angle 1, the angle is equal to the big arc minus the small arc that we just found divided by 2. That's 28 degrees. Okay, so that means the measure angle 1 is 28 degrees. And that is the answer to number 12. Alright, number 13 is a relatively simple problem. This is an inscribed angle. Alright, we're looking for angle 1 again. Alright, that's our target right here. Okay, so angle 1 is an inscribed angle. So we are dealing with this situation where the angle is half the arc. You know, so if I had an arc like this was 200, this would be 100. Okay, so if I knew this arc, I could just divide by 2 and that would give me the angle. I don't have this arc, but I have this major arc given. Together they make up the entire circle, so I can just subtract from 360. So I can just do 360 minus 234. Okay, that is 126. Alright, so that tells us that this angle, this arc over here is 126. Alright, so if I take that and divide by 2, that'll give me the arc. So, that'll give me the angle. Alright, so that's going to be 63. So that's why the measure of angle 1 is 63 degrees. Alright, here's a whole other way you could have done it. This angle over here, is an inscribed angle, and this 234 degrees is the arc that goes, the angle that goes with it. So this angle should be half of this arc. So I believe that's 117. Okay, I just did 234 divided by 2. So if this is 117, and we really want angle 1, you see the straight line here. These two angles have to be supplementary. They have to add up to 180 degrees. So at that point, I could just do 180 minus 117, and that is 63 degrees. So that's another way we can find the measure of angle 1. Either way, this is the answer to number 13. Alright, here is another one of those tricky problems like we did, I think it was number 12, where it's like having two problems in one that you have to solve in a row. What do you bet there will be a problem like this on the quiz? What do you bet? Okay, so you see that we're dealing with an angle outside the circle. So you ask yourself, what's the formula for that again? And here it is. The angle is equal to the big arc minus the small arc divided by 2. So you look at the picture, and so you know we got the angle, and now how about this big arc and small arc business? Okay, well, here is the big arc that is being intercepted by the angle, and here is the small arc that's being intercepted. The trouble is, we have the big arc, we don't have the small arc. So we need to find the small arc before we can finish the problem. So we have to abandon this problem for a minute and do a little side problem to find the missing arc. And here's the side problem. Alright, look what I did here. I just recopied this same picture. Okay, see the crossing lines, and we have the big arc and the small arc. Alright, I just recopied that. All I did was I took out the angle, because the angle is irrelevant for this part of the problem. So we want to be able to do angle equals big arc minus small arc divided by 2, but we don't have the small arc. But if you look at this picture, we have everything we need to find the small arc. So that's the key. You don't have to redraw the picture, but in your mind you have to be able to sort of ignore the angle, okay, to sort of scribble it out or just mentally erase it. So you can do what I'm doing here. In your mind, only look at this. So when you look at this part of the picture, we are dealing with this situation. An angle inside the circle. The angle will equal arc plus arc divided by 2. Okay, so the angle is 93 degrees. So if I go ahead and do that formula, it's going to look like this. Angle equals arc plus arc divided by 2. It doesn't matter which comes first, alright, the big arc or the small arc. Addition is commutative, so you can write it either way. But I need to solve this so I can find the small arc. So I will divide both sides by 2. I will multiply both sides by 2, so these will cancel out. Okay, and this is going to make, so this is going to make 186 is equal to x plus 142. So I'll just subtract 142 from both sides. Okay, so this is going to be 44. Alright, so that is the measure of the small arc here. Alright, which is this. So that tells me that this arc is 44 degrees. Now I have enough information to go back and solve for the angle. So remember, when the angle is outside the circle, the angle equals big arc minus small arc divided by 2. So I'm just talking about this right here. So the measure of angle 1 will equal the big arc minus the small arc, whoops, I said the big arc minus the small arc divided by 2. Okay, so that looks like this. That is 49 degrees. And so that's the final answer. Alright, so the measure of angle 1 is 49 degrees. So that's the answer number 14. Alright, this is the last problem. You are watching fireworks over San Diego Bay as you sail away in a boat. So this is the boat, these are the fireworks. The highest point the fireworks reach is F, about 0.2 miles above the bay. Okay, so right there, let's just go ahead and mark that down. So this is 0.2 miles. Okay, and your eyes are about 0.01 miles above the water. Okay. I feel like I should zoom in. So they're saying this little portion right here is 0.01 miles up. At point B, you can no longer see the fireworks because of the curvature of the Earth. Alright, so if you were down here, you could not see the fireworks. Alright, the radius of the Earth is about 4,000 miles. Okay, let's put that in the picture. Alright, I see 3 radii here. Okay, and so they all should be 4,000 miles. So just understand, I can't really draw sideways, but this is 4,000 miles. This is 4,000 miles. And this is 4,000 miles. Alright, all of those are 4,000 miles. Alright, we're supposed to find the measure of arc SB to the nearest tenth of a degree. Alright, so we're supposed to find the measure of arc SB, so that's this right here. But we know that when the angle is at the center of the circle, like this, the angle and the arc measure are equal. So let's use that. So in other words, if we knew what this angle was, it's going to be the same number of degrees. So that's all we have to do is figure out what this angle is. And obviously this angle is really 2 angles. So we need to find them both. Now it will be helpful to know that this is a right triangle. Okay, because a radius and a tangent are always perpendicular. So we know that these are right triangles. So we can use our trigonometry, you know, tangent, sine, cosine, that type of thing. So if I want to find angle theta here, for example, I'll put a quick theta right here. Alright, I know it's been a while, but the trig function, okay, so I have this 4,000 and I have this 4,000.2 miles. It's a little bit extra. So if I want to find out what this angle is, I've got the adjacent leg and then I've got the hypotenuse. Okay, so adjacent and hypotenuse, that was the cosine function, if you can recall. So the cosine of theta, okay, maybe I'll call it theta 1. Okay, because I also have theta 2 coming. So cosine of theta 1 is adjacent over hypotenuse. So that's 4,000 miles. Alright, over 4,000.2. Okay, that's a little extra. 4,000 plus 0.2, so 4,000.2. And of course we remember that if we want the angle, we need the inverse trig function. So theta 1 is going to equal the inverse cosine of 4,000 over 4,000.2. Why did I turn this into a Q? I don't know. I can't tell you. Alright, but theta 1, now this is a job for the calculator, of course. Slide that over a little bit. So I need the inverse cosine, so I'll do second cosine, and it was 4,000 over 4,000.2. Okay, so this is a very small angle, is less than 1 degree. It is 0.57 degrees. Okay, so that's the first piece of the angle. Now let's go after theta 2. I think I'll do this one in purple. Okay, yeah, so this is theta 2. Similar situation, alright? Again, we have the hypotenuse, but this is 4,000.01, alright, adding this little bit. And still, this 4,000 is the adjacent leg. So it's still adjacent over hypotenuse. So once again, we're going to do the cosine function. So we're going to say the cosine of theta 2 is going to equal adjacent over hypotenuse. So that's 4,000 over 4,000.01. And once again, if I want the angle, I'm going to need the inverse trig function. So it'll be the inverse cosine of 4,000 over 4,000.01. Alright, so I'm going to put this in a calculator. Okay, you know what, I feel like just editing this because it's sort of a lot to type in. So I'm just going to edit and make this 0.01. Whoops, extra decimal. Okay, so I got the inverse cosine of 4,000 over 4,000.01. Kabam! So, this is 0.13 degrees. I'm rounding up. Okay, so the angle that we are looking for will be the total angle of the sum of those two, right? So so what I'm talking about is theta 1 plus theta 2. All right, that's going to equal 0.57 plus 0.13. Alright, and that turns out to be 0.7. Okay, 0.7 degrees. And remember, that angle, that the sum of these angles is the same as the arc because it's at the center. So I will say the measure of arc SB turned out to be 0.7 degrees. And there it is, a very small angle indeed, almost 1 degree. Okay, and that, my friends, was the answer to number 15. And that is the end of this lesson. As always, I hope that it was helpful to you, and I hope to see you on the next video.